Class we discussed about Huffman coding technique. Today we'll solve some more problem to understand the Huffman coding technique in much better way. Consider 5 messages. M1, M2, M3, M4 and M5 with probabilities 0.4, 0.2, 0.2, 0.1 and 0.1 respectively. Find Huffman codes by moving combined symbol A as high as possible, B as low as possible. Compare the average code word length. Compare the average code word length L bar and variance say sigma square. So we are going to solve this problem. We are going to find Huffman coding by using moving combined symbol as high as possible and moving the combined symbol as low as possible. First I'll start with moving the combined symbol as high as possible. As we discussed in first Huffman coding, we have to arrange the symbols in descending order of probability. If you look at it, all the symbols or messages are in the descending order only. So let me write the messages. M1, M2, M3, M4 and M5. Probabilities are 0.4, 0.2, 0.2, 0.1 and 0.1. After writing messages in descending order, for the lowest probable symbols, you have to assign a 0 and 1. So for these two, you have to assign a 0 and 1. If I combine these two lowest probabilities, I'll get a new symbol whose probability will be sum of these two probabilities. That is 0.1 plus 0.1. So I'll get 0.2. That 0.2 can be arranged as we discussed earlier. This can be arranged above this 0.2 or below this 0.2. If I arrange it above this 0.2, I call it as high as possible. If I arrange this combination below this 0.2, I call it as low as possible. Since I'm going to follow as high as possible procedure, the combined symbol should be moved above this 0.2. That means I have to retain this 0.4. Because of combining these two, I'll get 0.2. That I have to keep it above this list. So I have to write 0.2. This 0.2 is contributed by combining the two lowest probable symbols. This 0.2 we have to bring it down. This 0.2 also we have to bring it down. At this point of time, you have to keep one thing in your mind. Whenever you combine two probable symbols, the total number of symbols will be get reduced by 1. That means if I have 5 symbols, now it will be 4. Going on, it get reduces. You have to proceed till you have been left with only 2 messages for which you have to assign a 0 and 1. Now I have to combine the two lowest probable symbols. So here 0.2 and 0.2 are lowest. I have to assign a 0 and 1. If I combine this 0.2, 0.2, I'll get 0.4. Again, I have to place it in the list in the descending order, but it has to be in as high as possible. So there is 1.4. So this is supposed to be at the top. So the point 4 is obtained by combining the two lowest probable symbols. Then bring this point 4 down, bring this point 2 down. Now earlier I had 4 symbols, now it will be reduced by 3. Keeping on it get reduces by 1. Now for these two lowest symbols, I have to assign a 0 and 1. If I add these two, I'll get 0.6. There is no 0.6, so it's supposed to be at the top only. So 0.6. This 0.4 you have to bring it down. Now I have been left out with only 2 symbols for which I have to assign a 0 and 1. Now I need to find the code word. Enumerate message, probability, code word and code length. There are 5 messages: M1, M2, M3, M4, M5 with probabilities 0.4, 0.2, 0.2, 0.1 and 0.1. Now let us find the code word, then code length. As we discussed earlier, the code word can be obtained by tracking backward zeros and ones assigned to that symbol as well as its successors. But tracking backward is difficult. We track forward, but we write it in reverse order. So the code word for M1 will be track it. 0 we have been assigned. 0 we have been assigned. So if I write it in reverse order, 0 0 will be 0 0 only. Similarly, you have to repeat the procedure for M2, M3, M4 and M5. M2 the code word will be track the zeros and ones, write it in reverse order. So 0 1. If I write it in reverse order, 1 0. Similarly for M3, the code word can be obtained by tracking forward and writing it in reverse order. So here we have been assigned 1 1. If I write it in reverse order, it will be 1 1. For M4, the code word will be 0 1 0. Even I write it in reverse order, it will be 0 1 0 only. For M5, 1 1 0. So if I write it in reverse order, 0 1 1. As we discussed earlier, code length is nothing but number of bits in the code word. Here we have 2. Here we have 2, 2, 3, 3. After finding the code word, we need to compute average code word length L bar and variance sigma square. The formula for computing average code word length L bar is equal to summation k is equal to 1 to n pk into lk, where pk is nothing but probability of occurrence, lk is nothing but length of the code word. We know the probability of occurrence and length. If you multiply, so 0.4 into 2 plus 0.2 into 2 plus 0.2 into 2 plus 0.1 into 3 plus 0.1 into 3 to lead for the value L bar is equal to 2.2 bits per message. Now we have to find variance sigma square. The formula for finding variance sigma square is equal to summation k is equal to 1 to n pk into lk minus L bar the whole square, where lk is nothing but length of the code word, L bar is nothing but average code word length. If I substitute the values here, since n takes the value 1 to 5. So k is equal to 1 to 5. Pk into Lk minus L bar the whole square. We know the probability of occurrence and length of the code word. So 0.4 into 2 minus L bar is 2.2 whole square plus for the next message 0.2 is the probability of occurrence. So 0.2 into Lk is 2 minus 2.2 whole square plus for the third message 0.2 into 2 minus 2.2 whole square. For M4 0.1 into 3 minus 2.2 whole square. For the last message 0.1 into 3 minus 2.2 whole square. If you compute the value for variance, it will be 0.16. Now I have to repeat the procedure for moving combined symbol as low as possible, and I have to repeat the procedure. I have to find out L bar and variance. To do so, again you have to write the messages probability. There are 5 messages: M1, M2, M3, M4, M5 with the probabilities 0.4, 0.2, 0.2, 0.1 and 0.1. Since messages are there in the descending order, I have been taken it as it is. Otherwise, you have to write it in decreasing order. After writing the messages in decreasing order, for the lowest 2 probable symbol, you have to assign a 0 and 1. If we combine these 2 lowest probable symbols, you will get 0.2. That 0.2 again should be placed in the order descending order only. When you place it, already we kept as high as possible. That means above this 0.2 we have been arranged. Now I have to arrange it as low as possible. That means the combined symbol will be kept down this 0.2. If you do so, so this 0.4 you have to retain, this 0.2 you have to retain, this 0.2 you have to retain. Because of combining these two, I'll get another 0.2. In as high as possible, we kept this 0.2 above this 0.2, whereas now we are keeping it down this 0.2. Now let us see what is the impact it can create in terms of average code word length and variance. As I said earlier, whenever you combine the number of symbols, the total number of symbols will be reduced by 1. Now you can understand that we have 5 here, it has been reduced to 4. Keeping on reduces, you have to proceed till you have been left out with only 2 source symbols for which a 0 and 1 to be assigned. So now I have to combine these 2 lowest probable symbols. I have to assign a 0 and 1. If I combine these 2, I will get 0.4. I have this 0.4. So that means this 0.4 to be kept down this 0.4 because we are moving as low as possible. So maintain this 0.4 as it is. Because of combining these 2 symbols, I'll get one more 0.4. That need to be kept below this 0.4. Now you bring this 0.2 down. Again, you have to repeat the procedure. For the lowest 2 probable symbol, you have to assign a 0 and 1. Combine these 2, you get 0.6. There is no 0.6, so it's supposed to be at the top only. So you'll have 0.6 because of combining these 2 lowest probable symbols, and you have to bring this 0.4 down. Again, you have to assign a 0 and 1 for the 2 probable symbols. Now you have to find the code word as we discussed earlier. The code word can be obtained by moving backward, zeros and one assigned to that number as well as its successors. But we do tracking forward, we write it in reverse order. So write down message, probability, code word and code rate. Sorry, code length. So there are 5 messages, M1, M2, M3, M4 and M5. We need to write the probabilities, 0.4, 0.2, 0.2, zero point 0.1 and 0.1. Now we need to find the code word for M1. So code word for M1 can be obtained by track forward, write it in reverse order. For M1, we have been assigned only 1. So even I write it in reverse order, it will be 1 only. For M2, fact this 1 we have been assigned, 0 we have been assigned. If I write it in reverse order, we'll get 0, 1. I'll repeat again. For M2, 1, 0, so 0, 1. For M3, 0, 0, 0. If you write it in reverse order, again 0, 0, 0 only. For M4, 0, 1, 0, 0. So 0, 0, 1, 0. For M5, 1, 1, 0, 0. So 0, 0, 1, 1. So track forward, write it in reverse order to get the code word for all the messages. After finding the code word, code length will be number of bits in the code word. So we have only 1 bit. There are 2 bits. There are 3 bits. There are 4 bits. There are 4 bits. Now you can find out average code word length L bar. L bar is equal to, formula already I have been written it. Summation k is equal to 1 to n, here 1 to 5, pk into lk. So pk we know, lk we know. So 0.4 into 1 plus 0.2 into 2 plus 0.2 into 3 plus 0.1 into 4 plus 0.1 into 4. If you find the L bar value, you will get the same answer, that is 2.2 bits per message. Now let us repeat to find out variance for as low as possible case. We know that variance sigma square is equal to summation k is equal to 1 to n, here 1 to 5, pk into lk minus L bar the whole square, where pk is probability of occurrence of the symbol, lk is length of the symbol, L bar is average code word length. By substituting all the values, that is here 0.4 into lk is 1 minus L bar is 2.2 whole square plus 0.2 into lk is 2 minus 2.2 whole square plus 0.2, the length is 3, so 3 minus 2.2 whole square plus 0.1 into 4 minus 2.2 whole square plus 0.1 into 4 minus 2.2 whole square. It will lead for the value of variance as, so sigma square is equal to 1.36. They asked us to compare average code word length and variance. If you compare the average code word length for average code word length L bar for as high as possible is 2.2 bits per message. Here also you can look at it for as low as possible 2.2 bits per message. That means there is no change in terms of average code word length. If you look at it in terms of variance, here it is going to be 0.16 for as high as possible, whereas as low as possible it is going to be 1.36. From that it is clear that whenever we go for as high as possible, that leads for lower variance, whereas whenever you go for as low as possible, to lead for higher variance. So it is preferred to go for as low as possible because the variance is going to be much lower. Further, you can note down that the code word is going to be different for second Huffman code than that of first Huffman code. So code word will be different when you go for as low as possible and as high as possible. However, the code word length are going to be same, only there will be a difference in terms of variance. Entropy, of course, it is going to be same. That's what, even if you find efficiency, both the method will provide you same efficiency. But it is always advised to go for as high as possible since it leads for minimum variance. So unless otherwise it is asked as low as possible, you have to move always the combined symbol as high as possible. Let us solve one more problem based on Huffman coding technique. Using Huffman code, encode the symbols, encode the symbols S1, S2, S3, S4, S5 and S6. S1, S2, S3, S4, S5 and S6 with the probabilities point 0.2, 0.3, 0.25, 0.05, 0.08 and 0.12 respectively. And 0.12 respectively. Find efficiency and redundancy. Find efficiency and redundancy. Whether the code word corresponding to the source symbols are, whether the code word corresponding to the source symbols are uniquely decodable. Uniquely decodable. As we discussed in Huffman coding, first we have to write the messages in descending order of probability. So if you look at it, the messages are not in the proper order. It is not in the descending order. So the first you write it in the descending order. So S2 comes first. So write it as symbols, probability, so S2 is going to have 0.3. So S2 is 0.3 followed by 0.25, that is S4. Then next AST is point 2, that is S1. Then 0.12, that is S6. 0.12 followed by 0.08, that is S5. Followed by 0.05. 0.3 is S2. 0.25 is S3. I made mistake. Please correct it. So S5. 0.05 is S4. So first messages are written in the descending order of probability. Now you check it out. 0.3, 0.25, 0.2, 0.12, 0.08, 0.05. Yeah, it is in descending order. Now for the lowest two probable symbols, you have to assign a 0 and 1. Now you have to add these two, you will get a new symbol that you have to place it in the list in the descending order. If you add these two, you will get 0.13. So I have to keep it above this 0.12. So retain this 0.3, retain this 0.25, retain this 0.2. Because of adding these two, I'll get 0.13. You keep it above this 0.12. Now you bring this 0.12 down. Right? Earlier we had 6 symbols. Now it will be reduced to 5 because we have been combined the lowest two probable symbols. Now add these two, you'll get assign a 0 and 1. Add these two, you'll get 0.25. I have 0.25. As I advised, this 0.25 should be moved above this 0.25. That is called arranging combined symbol as high as possible. So retain this 0.3 as it is. So by combining these two symbols, you'll get 0.25. Then bring this 0.25 down and bring this 0.2 down. Now for the lowest two probable symbols, you assign a 0 and 1. Add these two, you get 0.45. So I have to keep it at the top, 0.45. Then bring this 0.3 down. Bring this 0.25 down. You have to repeat the procedure till you have been left out with only two source symbols for which a 0 and 1 to be assigned. Now combine these two for which you assign a 0 and 1. If you add these two, you will get 0.55. So keep it at the top. Bring this 0.45 down. Now you assign a 0 and 1 for these two symbols. Now we need to find code word. For that you write it message. Here not message, it is given as symbol. So symbol probability code word and code length. Code word and code length. There are 6 symbols we have. So S1, S2, S3, S4, S5 and S6. Probabilities are for S1 it is 0.2. For S2 it is 0.3. For S3 it is 0.25. For S4 it is 0.05. S5 it is 0.08. And S6 it is 0.12. For finding code word, you track forward and write it in reverse order. For S1, 1, 1. If even I write it reverse order, it will be 1, 1 only. Then for S2, track this 0, 0. Even you write it in reverse order, you will get 0, 0 only. For S3, 0, 1. So if you write it in reverse order, it will be 1, 0. For S4, 1, 0, 1, 0. So 0, 1, 0, 1. For S5, 0, 0, 1, 0. So 0, 1, 0, 0. For S6, 1, 1, 0. So 0, 1, 1. Then find out the code length. Code length is nothing but number of bits in the code. 2, 2, 2, 4, 4, and 3. Now you find out efficiency. The formula for finding efficiency is eta is equal to entropy of the source h of x by L bar. The formula for finding entropy h of x is equal to minus summation k is equal to 1 to n pk log pk to the base 2. As I said earlier, to the base 2 we cannot use it in calculator, so divided by log 2. So this formula can be rewritten as minus 1 by 0.3010 into summation k is equal to 1 to n, here 1 to 6, there are 6 symbols, pk into log pk to the base 10. Now you substitute probability of occurrence for all the symbols, that is minus 1 by 0.3010 into 0.2 log 0.2 plus 0.3 log 0.3 plus 0.25 log 0.25 plus 0.05 log 0.05 plus 0.08 log 0.08 plus 0.12 log 0.12. If you find the value for entropy, it will be 2.36 bits per symbol. The message, the unit for entropy may be bits per symbol or bits per message, depending upon whether it is given as message or symbol. If it is given as message, you have to write bits per message. If it is given as symbol, it should be bits per symbol. Similarly, you have to find L bar. The formula for L bar is equal to summation k is equal to 1 to n pk into lk. By substituting probability of occurrence and length, that is 0.2 into 2 plus 0.3 into 2 plus 0.25 into 2 plus 0.05 into 4 plus 0.08 into 4 plus 0.12 into 3. You will get the value for L bar as 2.38 bits per symbol. Now we know the entropy, we know the L bar, so we are in the position to find out efficiency eta. Eta is equal to h of x, that is 2.36 by 2.38. You will get the value as 0.9916. Therefore, if I express eta in terms of percentage, it will be 99.16%. Now let us find redundancy. Redundancy R is equal to 1 minus efficiency, that is 1 minus 0.9916, which which will be equal to 0.0084. Therefore, R in terms of percentage will be 0.84. Roughly, it is equal to 0.1 percentage. At this point of time, I hope you might be understand how to do Huffman coding and Shannon-Furman coding. Now, take it as assignment 2. Already, we have been given assignment 1. We asked you to submit through Google Classroom. I hope you might be submitted at this point of time. Now, let me give the assignment 2 using Huffman coding technique. Solve this and submit through Google Classroom. Consider a source with 8 symbols. Consider a source with 8 symbols: x1, x2, x3, x4, x5, x6, x7, x8. With the probabilities 0.22, 0.20, 0.18, 0.15, 0.10, 0.08, 0.05, and 0.02 respectively. Apply Huffman coding technique. Find efficiency and redundancy. If you look this problem, already the symbols are given in the descending order of probability. So you need not arrange it in the descending order. Already it is there in descending order. Then you have to proceed with the Huffman coding technique. You have to find efficiency and redundancy. Thank you.